Hey everyone, moving on from the trigonometry integration, we are left with only a few more integrals, and I'll show you two of the last four. So if you might find this familiar, right? 1 over root a squared minus x squared and 1 over x squared plus a squared. So maybe recall a bit, you notice that these are your derivatives, right? Kind of, from the inverse trigonometry, namely sine inverse fx, which would end up giving you f prime x over root 1 minus fx whole thing square. And for the other one, tangent inverse, right? So d dx of tangent inverse fx, you would get back f prime x over 1 plus fx square. Fantastic. So what would be the derivative? So what would be the integral of 1 over root a squared minus x squared and 1 over x squared plus a squared? Well, flip through MF26 and these are the equations that will appear. So we have integral of 1 over x squared plus a squared equals to 1 over a tangent inverse x over a. 1 over root a squared minus x squared equals to sine inverse x over a. Well, the proof is kind of similar, right? What I do is, well, I get 1 over x squared plus a squared. It will become 1 over x squared over a squared plus 1, which means I will have a 1 over a squared. I factorize out 1 over a squared. And it basically gives me 1 over a over x over a whole thing squared plus 1 times the constant 1 over a. If you notice, this is f prime x and this is my fx whole thing squared. And if you notice from the formula here, that's why I'll get 1 over a tangent inverse x over a. Right? Same thing for this one, it's almost the same method, just that now let me see, I have 1 over root a squared minus x squared. I convert it to 1 over root 1 minus x over a whole thing squared, and then because I factorize out root a squared, so it's basically 1 over a. So then basically this is your fx square, this is your f prime square, and if you notice, it's basically the whole side here is basically just sine inverse x over a. As such, we kind of derive this general formula from these two equations here. So if we have y 1 over root a squared minus fx squared, then, well, to make it even more general, let's put it s prime f prime x. Then we'll have the integral of y dx being sine inverse fx over a. Then if we have 1 f prime x over fx square plus a, we will have 1 over a tangent inverse fx over a, and this will be our two integrals, obviously not forgetting our plus c's. So for example, if I were to integrate, let's say 1 over 4x squared plus 6, alright? So integrate 1 over 4x squared plus 6 dx. This would give me, following the formula, 1 over root 6 tangent inverse 2x, right? 4x squared is basically 2x whole thing squared over root 6. And then I must divide by the differential inside, which is 2x, right? So I differentiate, it is giving back 2. So divide by 2. So I get 1 over 2 root 6 tangent inverse 2x root 6, and obviously plus c. And let's look at the sine inverse one. So let's say I want to integrate 1 over root a squared minus 3x squared. It will equals to, well, dx, it will be equals to, again, sine inverse. Start with the sine inverse first. Well, because it's 3x squared, so I'll get root 3x over a, then plus c. Then I must divide by the derivative of the function, which is root 3x, so divide by root 3. So 1 over root 3. So there we have it, the general formula for your integrals of f prime x over a square minus fx square and f prime x over fx square plus a square.